Okay. Hello everyone. This is joint work from between UTS, University of Technology Sydney, and Data 61. Our paper is about image captioning. We proposed the fine-grained and semantic-guided visual attention model. First, the research task is about the image captioning. It means that I give you an image, it will just generate a sentence to describe the image. Here is several examples. For the first one, a guy is playing soccer, so the ground truth is like a boy is playing soccer on a field. For the normal way to do the image captioning is like CNN plus long-short-term memory framework. So there are several limits here. The first one is called fixed low-grade resolution. If we use VGG-based CNN encoder, so it only supports grid resolution like 14 by 14, or even if you use ResNet, it will be smaller. The other way is like because we separate we split the image into several parts. For each part, it may include several objects in there, or maybe it's a large object. Will be split into several grids. The other one is that because it's based object, if you use ImageNet, there will be fixed objects there. You cannot get some object like sky or grass. So we propose FCN and LSTM framework. So this is the first work. We apply segmentation framework into image captioning to solve the first problem, like the grid resolution. Because we use segmentation framework, so we can get pixel level labeling. But for our work, we just use the 27 by 27. The other way is like we use the salience-related semantic correspondence. It means that in each grid, we can get the label for each pixel. It means that we can get fine-grained labels and fine-grained image features. The other way is that as we mentioned that there is no label for grass or sky, but for the segmentation, we have this label. We joint train a model to solve all these problems. Here is the relative works. So the first one is like a spatial visual attention model. They just use the objects into the CNN network. The other way is like semantic attention model. They use the attention model, but they ignore the objects here. So here is our framework. So the first one is that we replace the CNN with FCN network for segmentation. The other way is that we can use the segmentation result to get the semantic label and the semantic features. And we feed these labels and features into a soft attention model and to generate the final sentence. Here is the structure here is maybe too complicated, so you can come to our poster. I will explain that for you. We proposed the pooling layer. We call the saliency pooling layer because we have the labels for each pixel in theory. So we can, for each grid, we can have many labels here. We just use the majority voting in that grid, and we can have the saliency-based feature and a saliency-based label. The other is like attention model. Nowadays, a lot of people use attention. In our way, we use the visual feature as the semantic feature and the semantic label. We combine them together to join the final attention model. We test our method on MS Coco captioning dataset and Coco staff dataset. We use the public evaluation metrics like n-gram, and we train our model and test it. Here is the result. Our model can beat the other state-of-the-art method. And for the resolution, we test a different kind of resolution, like 14 by 14 and 27 by 27. We call 27 by 27 will get much better result. Here is the example here. The boy is playing soccer. If you use attention model like this one, for the soccer, we can get the importance here only focus on soccer. If you ignore the attention model, it's like the messy. We don't care. Actually, we don't care about the grass or the people. We only care the soccer here. The other is that our model can generate some meaningful words here, like the street or sky. If you don't use that, so you cannot get that. Okay, thank you very much. Please come to our poster for more details.